You know, one thing about studying calculus remotely like this is, I kind of miss my friends. But if you don't consider myself in your group of friends, I'm going to go visit a dear old friend of mine. This was a function that we did back in a previous chapter. We had f of x is 1/5 x to the 5th power minus 5/3 x cubed plus 4x plus 1. And what we did is that we came up with a wonderful graph of this. We knew exactly where the relative max and relative min heights were, where it went from increasing to decreasing, where it went from concave down to concave up and vice versa, and where the points of inflection were. So what I'm going to do now is I'm just going to utilize the theorems that we just learned about on the closed interval -1 to 2. Now, what I want to do with those theorems is I want to find lower and upper bounds for this definite integral from -1 to 2 of f of x with respect to x, where of course that f of x is that long thing there that I didn't want to rewrite out. So we need to find a lower limit and an upper limit for a range for where this might actually be. So I'm just going to draw a picture here, and here's -1 right here, and here's 2 right there. So basically what I have is the definite integral actually gives the visual of when it's above the x-axis, the area under the curve, right? So it would be this all the way to where it crossed the x-axis left of the origin there, things of that nature. And of course this would be considered negative area, it's going to be a negative number left of where it crossed the x-axis, somewhere between -1 and 0, which we did calculate that in a previous video to the nearest thousandth anyway. So the whole thing is, this is going to be positive, this is going to be negative. It looks like there's probably more positive than there is negative here, so chances are it's some kind of positive number. But in the meantime, let's just look at what we did here for the upper and lower bounds. Well, first of all, f is a polynomial, right? And what do you know about polynomials? They're continuous on all real numbers. So certainly this polynomial is going to be continuous on that closed interval. So the other thing that you know is if f of x is continuous on that closed interval, then it's going to be integrable on that closed interval as well. So in other words, the definite integral from -1 to 2 of f of x with respect to x actually does exist, right? And then what we're going to do is we're going to have an upper bound. So if you remember, we can say, hey, this is going to be less than or equal to the absolute max on that closed interval times b minus a, right? And then we also know that it's going to be greater than or equal to the absolute minimum height times b minus a from the theorem that we just proved in the last video. So let's just take a look at this to come up with a real quick lower and upper bound with this. Let's start with the lower bound. The absolute minimum height on this, once again, if you don't believe me, go look for that video where we graphed this thing so meticulously without technology. But we know the absolute minimum height occurred when x equals -1. And we know that absolute minimum height, which I've got it written up very tiny there, but it's -1 and 8/15 is actually how low. So these tick marks all represents ones. But anyway, on this closed interval, the absolute minimum height actually occurred at that left endpoint. Now I could have actually went from -2 to +2, and I would still have to use -1 and 8/15 because even if I extend it over here, the absolute minimum height is actually lower than where it is between -2 and -1 there for the x's. So anyway, but b minus a in this case would be 2 minus a -1. And 2 minus a -1, of course, is 3. And so what I'm going to do is I'm going to simplify this a little bit. This is -15 plus 8 is or 15 plus 8 is -23, right? Well, it's 23, but it's going to be a negative number. So it's -23/15 is -1 and 8/15. So however you want to say that appropriately, and then times 3, right? So what I can do here is I can cancel this out, and then -23 divided by 5 is -4 3/5. So -4 3/5 is going to be the lower bound, and that's going to be less than or equal to my definite integral there from -1 to 2 of f of x with respect to x. And once again, I'm not going to waste your time writing out what f of x is. F of x is right here. So in your notes, you can go ahead and put that in. And then I need to find the upper bound on that as well. So I need to find the biggest that it could possibly be. And that's by taking the absolute max height on this closed interval, which actually occurs right here. So this is the absolute max height, occurs when x equals 1. We verified that when we graphed this out before. So the absolute maximum height was actually a relative maximum height for a while here, but knowing what that looks like, this is going to be less than or equal to then 3 8/15 times b minus a is the same 2 minus a minus 1. And once again, multiplying that out, that's 45 plus 8 is 53/15 times 3, and I'm going to cancel the 3 with that, and 53 divided by 5 is going to be 10 3/5. So you can leave it improper if you want as 53/5, but basically as a real number, I know that the definite integral from -1 to 2 of f of x with respect to x for this function on the closed interval, of course, -1 to 2 is somewhere on or in between -4 3/5 and 10 3/5. And what we're going to do here in a future video is we're actually going to be able to come back and find the exact area of this, and we'll notice that it'll land right in between those two boundaries.